So the next part is sensing and sensing assemblies. So the fiber optic brings the light from the panel, from the scintillator panel, into one point, and therefore we need to read these single photon counts, somewhere between 10 to 30 photons that end up near the sensor. The way we can do that is using a MPPC, which is a single photon counter. It's a multi-pixel photon counter by Hamamatsu, also sometimes called an SIPM by the generic name. So Hamamatsu calls them MPPCs. These are quite small. They have 50 by 50 pixels, I believe, 2050 VES, and there's 4 pads in the bottom. And so these need to be run with a high voltage, as well as they have some current and power requirements and temperature regulation requirements. So these get mounted onto these assemblies that we have. So here is an example assembly. Let me zoom. And this is a injection molded part with a custom circuit board with a connector for a cable as well as a screw for mounting. And this attaches, so that is assembled with these M1.6 screws into this plastic unit, and it is made so that when these two fiber optics land on this side, they are aligned with where the SIPM rests. So here is an assembled unit. If you take a look at this, we can see a UFL connector on this side and a MPPC on this side. This attaches to these panels with these pins and snaps into place, and this side can then be light tight because it's a black light blocking board, along with this connector on the other side which has no through vias, and a UFL cable is then used to take the signal away from the board, which is then taped over just for extra light blocking. And here's an example of a UFL connector leaving the panel. Once the signal is out of the board, and then the next step would be to connect it to the electronics, which does the amplification and the signal processing and provides the bias voltage. So that will be next.